Okay, everybody, to start with, I'm going to give you a problem. Okay, so we're going to graph this thing because that was a typical question off of quadratics A. And we started with the vertex. One of my students said that it was -2, -5. And then if you have to have 5 points, would you agree that you should stay near -2, like maybe -1, or maybe -3, or maybe 0? Those are all fairly close to the x value that we had in the first place. Maybe even +1. All right, so they should be numbers that are fairly close to -2. Now I'm going to use these, and you check and see if you get the same answers as I do. Once you've got the points, it'll be easy peasy. So let's just do 1 to see how you do it. If I were to put in -3, I'd put it right here. -3 plus 2 is -1. -1 squared is 1. 1 times 3 is 3. 3 minus 5 would be -2. Who had -3? -2. Excellent. Apparently I'm doing it right. Now find a few more points and then graph it, and that's one of the things you were asked to do. All right, Amelia, what did you get for when you stuck in -1? Could anybody else verify -2? Okay, cool. I know it feels weird that that's the same answer as the other one, but if you think about how the graph looks, at -2, -5, there was a low spot, but then there'd be 2 spots on either side that would have the same y value, so it makes sense. All right, Jackson, what did you get for when you stuck in 0? 7. And the last one, when you put in a 1, I'm guessing it's a 7. Did anybody put in a, oh no, wait, I'm wrong. I should have had you put in -4 and it would have been 7. But if I put in 1, let's see what it comes out to. 1 times 3 is 3, 3 squared is 9, 9 times 3 is 27 minus 5, 22, I think. Did anybody get 22? Uh-oh, what am I doing wrong? I'm putting in a 1 right here. Putting in a 1 right here. 1 plus 2 is 3, 3 squared is 9, 9 times 3 is 27. 27 minus, oh, what? What's wrong?
It should be 1 plus 2 equals 3.
Yep, and then 3 squared is 9, and then 9 times 3, 27, and then 27 minus 5. I'm pretty sure it's 22. Could somebody tell me I'm not crazy? Okay, good. I'm pretty sure it's 22. All right, so moral of the story, you graph a bunch of points. Do you guys remember how to do that? Okay, good. So that's one of the things we're reviewing on this cumulative test. All right, next thing that we should review. If I give you a graph, you got to be able to tell me what the equation was. Let's say that this spot right here is 5, 2. It's the vertex. Hint, it's an upside down parabola, and you know the vertex. Can you tell me the equation for that? Well, here's vertex form. What would be wrong with that? Yes? The graph is flipped, so there has to be a negative there. Now, have I told you enough information to be able to tell what the B number would be? Like, is there a stretch? Can you tell if there's a stretch? No, you can't tell from what I told you that there's a stretch, but you can tell it's upside down, right? So you got to have a negative there. Okay, could it be as nasty as that there's a stretch? Absolutely. Let me show you. Let's say that I told you that when you go over 1, you get to 6, but it's at 0. So this spot right here is on the graph, and when you went over 1, it went down 2 to the point 6, 0. Do you get how my x only went up 1, but my graph went down 2? Do you get that means the stretch factor was a 2? Okay. Now, once I have this equation, what if I asked you for what's f of 5? Do you get it's really simple once I've got the equation? But if they'd asked me that before I had the equation, it would have been super confusing. But once I've got the equation, I just stick in a 5, and I hope that you realize that it comes out to 2, which makes sense because I have the point 5 comma 2. Okay. Next, if I asked you to factor this, it should be like child's play. Go ahead and factor that because it'll tell you the x-intercepts. Ask me, I'll help.
Oh, for this,
Yep.
plug it in like that.
Yes, you can stick the 5 in. Yeah, stick it. Yes, exactly like that. And so then that becomes 0, and then that all becomes 0, but then the leftover is 2. Okay. I hope this was easy. X, and a plus and a minus. I always do my signs because that's negative. This must be a plus and a minus. There's no other way. Couldn't be plus plus, couldn't be minus minus. All right, and then the last thing is, how do I make a 9? Well, it's either 3 times 3, which doesn't work. That's important to know that it doesn't work. Some kids just think if anything multiplies to 9, then that goes there. No, the outside and the inside would have canceled then. Negative 3x and positive 3x, you wouldn't get negative 8. So 3 and 3 can't work, but it must be 9 and 1. And it's like that. And what if you had them backwards? You would have got positive 8x instead of negative, and then you would have switched the signs around. All right. Now here's one that I'm going to ask you to factor, but it's not as nice. Factor that. Did you know that you had to multiply it out first before you could factor it? X minus 4 times x minus 4 plus 3. X squared minus 8x plus 16 plus 3. So x squared minus 8x plus 19. I'm feeling like that's not going to factor, Mr. Server. It doesn't. But if you got this far, you at least knew what you're supposed to do to get it to factor. Pretty sure that the only factors of 19, well, wait, this has to be a minus and a minus. Did you know that? Because that's positive. It has to be 2 negatives because this is negative. There has to be at least 1 negative, so then they must both be negatives. And then how do I get a 19? Well, it's prime. It has to be a 19 and a 1, and there's no way to make that turn out to 8. Does this mean that there's no solutions to this?
Quadratic formula.
Quadratic formula, very good. But don't do it. That would be on quadratics B. On the quadratics B test, you would have had to know that there's no, it doesn't factor. And if you can factor it, you should, but after that, you go to the quadratic formula. All right. So then the last thing, there was a weird question that we had that was something like this. And we said that it had an axis of symmetry at, let's say, 4. My advice to you, to figure out what M is, I would sketch this. It's one of my best tips for anytime you have a complicated problem and you have a chance you could sketch it, well, sketch it. Because then when you see it, you'll be like, oh, it's a parabola. And I know where the axis of symmetry is. That's that dotted line, right? And I know one of the roots is at -5, right? And once you get that all set up, it'll become obvious what M has to be. Okay, so sketch this. Be quiet for a minute while you try to sketch. Remember, the dotted line is at 4. One of the roots is at -5. Fiona, tell me one thing you know about this graph.
The windows like down by 5, so it'll be like that one would be 4.
Okay. So here's where 4 is.
Because it's the axis of symmetry.
Here's where negative 5 is. What's there at 4?
The M.
M is 4?
Yeah.
Nope. All right. So
Wait,
what?
is it negative?
We might get there. One thing at a time. How about this? Would you agree that the axis of symmetry is at 4? I mean, it says that right there. So then there's a dotted line right there. So that can't be what M is. M is not that. Okay, so there's a dotted line that runs down there. Now the parabola is like, I don't know, maybe it's something like this. Is it a right side up parabola? Look. Is it a right side up parabola? No. See, it's negative in the front. So this must be an upside down parabola. So it must be a parabola that looks kind of like that. Except wait. One more thing we know. It's like little clues. X equals negative 5 is a big deal. It's one of the roots. So it must, this parabola here, this blue parabola, can't be down there. It has to touch right there. See, right there. So then my parabola must be more like this. Do you get what I mean? It has to be an upside down parabola, and it has to go through that. So then what's this other spot over here? Well, we need to know how far this is from here. That's a total of 9. So we got to go 9 in that direction. We got to go 9 spots over. And 9 plus 4 is 13. How many of you knew the answer was 13? Awesome. Okay. That was probably the hardest question of that test. If you draw a picture, though, it's not that bad. Okay. So there's a little bit of review of the hardest stuff from the quadratics A test. I mean, they're going to throw you some super softballs like, what's the vertex of this thing? Which by now you're probably good at. There is some complicated factoring, though. Gentlemen, pay attention. 49x squared minus 144. Can you factor that? Oh, yeah, this is one of those kind where you do the square root. 7x and 7x. That's how you start. This ring a bell? Plus and a minus. And then you do the square root of that, which is 12, here and here. Who had that one right? Okay, cool. Now, if I needed to, I could solve that and figure out there's some decimal that's the x-intercept, and there's some decimal over here that's the x-intercept. You go 7x minus 12 equals 0. 7x equals 12. Divide by 12. No, divided by 7, sorry. Guys, you're talking so much that it's really distracting me. Last chance, otherwise I'm moving you. 12 sevenths. That's one of my roots. Okay, now, harder question. What's the axis of symmetry of this? You might be like, but there's no B. But there is. It's just that B is something weird. Axis of symmetry formula, x equals negative b, what? No. That's the whole quadratic formula. Over 2 a. All right, negative b over 2a. So, what's b?
0.
B is 0. Very good. Okay, So if b is 0, do you get it doesn't even matter what this is? Because 0 divided by anything is 0. So we just figure out the axis of symmetry of this thing would have to be at 0. And it's a parabola, isn't it? And then, if I already know the axis of symmetry is at 0, I already know that the vertex would be at 0, comma, figure it out. The axis of symmetry is at 0, so what's the vertex? Zero comma negative 144. Because when you put a 0 in there, cancels out the first term. Y equals negative 144. That make sense? Okay. All right, there's a review of the stuff from the other test. Now, do you get I made a whole 35, like twice this long video to review for that test in the first place? I made a video. It's there if you want to go look it up. So if you had trouble on that test, and your bad test wasn't the one we just gave you, if your bad test was the one that was 2 weeks ago, quadratics A, you'd know by looking in the grade book. If you had a bad grade on that, you might want to go watch the whole review video for that. So, all right. So now, what we're going to do for the rest of the hour is I'm going to hand back your tests. You can do corrections on them if you had a rough test and you want to be able to replace this score. And then on Monday or Tuesday, you'll have the choice. If you studied over the weekend and you're all ready, you can just jump right in and take it on Monday and be done with the cumulative. And then on Tuesday, you'll just have a stop day. For those that don't feel ready, then you need to study that night, on Monday night, while everybody else is taking the test. They're already done with it. You'll take it the next day on Tuesday. So in class on Monday, you could just study for the test, take it Tuesday. If for some reason you intend to take it Tuesday, but then you get sick and you can't take it, you'll eventually take the cumulative. You'll take it when I get back then, if you aren't able to take it on Monday or Tuesday because you get sick or you're just not here because of a family vacation or something. All right, that's the plan for the next several days.